Hello, everyone. So I just have to start this right. My name is Lutfan. I'm from Tokyo Institute of Technology, and I'll be, on behalf of my other co-authors, I'll be talking about our paper, BatakJava, an object-oriented programming language with versions. Should remove my mask? And in this paper, basically, we propose a language that allows the use of multiple versions of a class in the same program while maintaining type safety with the objective of trying to solve some forms of dependency problems. First, let's see a very simple example of a program in which we have several locations where they depend on one similar dependency. Let's call it a graphics. And inside of that graphics, we have a class called rectangle, and we use it at different locations in our program. And just as our dependency and our own program are both softwares, they will go through updates throughout their life cycle, maybe to fix bugs or to just improve them and make them better. But the problem is, of course, something that we all have experienced in our work, possibly, when our dependency is updated with some form of incompatible updates. In this case, I give some simple two candidates. Maybe we can remove the method inside of the class rectangle, or possibly the behavior of that method inside of the class rectangle has been changed by the third-party developer. In that case, when we try to update our dependency, of course, we'll run into an error, either because we couldn't find the link for our method or because the behavior of our program is no longer the same. And for this kind of simple example, of course, it's probably easy to solve ourselves. We can easily force to change our own dependency in some way or another. But what happened is it would be much difficult for us to deal with this problem if our dependency is more complex. So we have some form of transitive dependency with that problematic graphics. In that case, even if we try to do something from our own program, for example, we can try to have both our direct dependency all use the same version of our indirect dependency, the problem might still happen, but in that case, we don't really have any access to those direct dependencies to even fix the problem that we have. So it can this indirect dependencies that we don't have control of can lead to some form of version locking to our own program. And this has been shown to actually discourage users from even maintaining and keeping their program up to date with the latest dependencies. And in such example, there are certainly situations where it would be better for us to actually be able to use multiple versions of our dependency, especially if we can keep them safe within our own program. So in this case, if we can have both the old version of this graphics and the new version of this graphics inside of our program while maintaining its safety, it would be helpful for the programmers. However, most programming languages do not allow that, of course, because we can have overlapping definitions in our program. And that brings us to what sort of started our research, is that what if instead of just having versions outside of a program, what if we have the versions as part of the language semantics, and language semantics itself intrinsically support multiple versions at the same time? And so we built on our previous work. So previously, we proposed a core calculus called lambda VL. So in that core calculus, we came up with the idea of programming with versions. And this lambda VL is a functional calculus. So in this calculus, there is something called a version value. So a version value looks like a record, but each element of it is actually tagged by a version. And so a value can have different values, different base values, depending on which version it's in. And we want to try to expand this idea to object-oriented programming. We want to see what we require, what we need to implement if we want to have this idea with things like data structures. And also, we found that the calculus that we had in our previous work was very restrictive, and we want to relax them so it's more useful when we want to deal with updates. And we came up with two different contributions. First, we made a prototype implementation of our idea in the form of a language called BatakJava, and we also formalized this language in a core calculus called FBJ. So with programming, if we have a programming language that has versions in it, what we expect that we can do then is that we can have multiple versions, of a same class, in this case, in our program. So this will give the users better control over their dependencies. And so for this given example, both the version, here I labeled them version 1 and version 2 of the class rectangle, can be both included in our program while being carefully checked within our program for type safety. Okay, next. So how exactly does a programmer would do programming with this kind of versioned programming language? So first, let's start with the class rectangle that we have from before. And we start with, this is the initial definition, so we just labeled the version 1. And in BatakJava, we require each class to be annotated with a version. And so it's a usual class definition. And then we have our own program where we use this class definition. So we just make the instance as usual. And then let's say that class rectangle is updated by removing its method. Now we have two different class rectangles, and we can still have access to both of these classes at the same time, and we want to use them in our program. Then there are two ways for us to create instances for these classes. Either we can just create instance as usual, where we would leave the versioning to the compiler to find out through an inference system, or a different way to do it is that if we want to make sure that the program behave in a way that we want to fix on a certain version, then we can use some form of version annotation on the instances. And from there, we leave it to the compiler to check for version consistency. We want each of the type annotation and the class instances inside of the program to be consistent. And in this case, it gives us this kind of checking. And from there, BatakJava is actually transpiled into Java by taking a very simple approach by renaming the class definitions and also by attaching the version to each of the type annotations within the program. Another thing that I've mentioned earlier is that we want to relax our previous work. And to do so, we actually do not put any kind of restriction in the way we change our class from one version to another. It is possible to change its superclass. It is possible to do fields addition and removals. You can see the X and Y are replaced by a pointer. And also it is possible to remove method and also add new methods as well. Next, so exactly how does it work within the constraint-based typing system? So the objective of the constraint-based typing system is to globally infer version for all the type annotations and the object instances. And right now it tries to find one consistent fixed version for each of the instances to compile to. So we'll see how it works with some very simple example. First, we have this program, and we have the class definitions above. So we have two different class rectangle version 1 and version 2. And the difference between them is that the version 1 has a rotate and the second one has a distance. And we have a class square here that extends on rectangle. And you can see here the version for the superclass of square is actually not specified, and it is also given to the compiler to find the correct version for it, as well as you can see the argument for the method as well. And inside of the program on the lower part of the slide, you can see that all of the instances and the type annotations are also unspecified. From there, I think we can easily intuitively see that given that there are two variables here, R1 and R2, and we invoke rotate on R1, which is only available in version 1, then we can easily infer that R1 has to be version 1. And by doing so, we indirectly also give the square version 1 its superclass, which is rectangle version 1. And for the other variable, because it's invoking something that's only available in version 2, it will also put constraint on R2 that it has to be version 2 as well. So in this case, it's very simple. And then we get all of these assignments, as I've mentioned before. So you can see the rectangle 1, which is the superclass, is version 1. The argument for distance, which is rectangle 5, is also version 1. And the instance for the R1 that invokes rotate, it is assigned with version 1 as well. because it invokes rotate, and the one for distance is assigned with version 2. And based on these assignments, we can easily convert them into a Java program that we can run normally as Java program. Okay, and then next we will see what happens with some problematic program. In this case, instead of having R2 invoke distance, we have R1 also invoke distance. And intuitively, we can see that R1 is invoking both method that is exclusive for version 1 and version 2. And intuitively, we can see that we can find a consistent version for R1. What exactly happened is that we can see easily what kind of constraints are actually generated behind it. So for the instance new square, we will focus on that instance, and we will assign it a type variable t. And when it first was assigned to this variable r1, it is given these constraints, which is it has to be a subtype of rectangle version 1 or 2. And the OR notation here comes from the fact that the type rectangle is not specified. And when we invoke those two methods, of course, the rotate is for version 1 and distance is for version 2, we get this conflicting constraints where T has to be a subtype of both version 1 and version 2. And this results in typing error because one instance cannot inherit from two different versions at the same time. Okay. And the BatakJava, this is the structure of the compiler for BatakJava. Basically, the extension is consisting of this main three parts. There's the constraint checker that generates the constraints and also do some forms of basic name checking and type checking. And the constraints we got from this constraint checker is passed to a solver. Right now, we use a third-party solver, which we use a Choco solver, constraint programming library for Java. And then from the solutions we got from that solver are then passed back to the generator to be used to convert our BatakJava programs into Java programs. Using this prototype, we simulated some form of method removals in a re-implementation of Java library. We did not re-implement the whole library, only a section of it. And using multi-versions of Guava, we implemented a simple file processing program. And our finding is that we find that it is possible for our program to have multiple versions of the implementation of Guava inside of it on different section and in different sections of the program, and also have some form of object passing between different versions as well. However, we also found some lessons that we need to improve on the implementation is that we find that version specification are also required to some part of the program so that we can direct the inference better. And we've also found that we also need some form of version polymorphism for in this compiler so that it can be helpful for user when they're doing multi-version programming. This is the formalization which is built on featherweight Java, and it is also equipped with a subject reduction property that actually just follows featherweight Java subject reduction property. If you want more detail, please check the paper. And of course, this is still a work in progress. We found some problems with it. One of it is the lack of some form of polymorphism. And if we look at the previous example, where you have the class square extending the class rectangle, if inside of our program we have different instances of square that are not actually related to each other, but they are using or inheriting from different versions of rectangle. Currently, the monomorphic constraint generation does not handle this, but it can easily be extendable for our future work. And of course, we have not conducted a proper prototype evaluation. So what we wanted to do is we want to conduct a user case study to measure the usability of our language in handling real-world dependency problems, instead of just using some form of artificial case studies. And also we want to compare it with other existing tools that try to deal with dependency problems. And we want to do some form of compiler evaluation to measure the limitation of the compiler when handling larger and more complex code bases. So to summarize my talk today, what we did in our research is we proposed a language with versions for object-oriented programming, and we implemented it in a prototype language called BatakJava, and we formalized it as well in the form of a core calculus called FBJ. And we, through this language, we enabled the usage of multiple versions of the same class in a program in a type-safe manner. And we found that it is useful for handling conflicting dependency updates. And that's it. Thank you for your attention.
Questions?
Thanks for talk. So I have two questions. The first one is, you mentioned the user is doing some sort of multi-version programming. So I'd like to know if there are some, you can also study some relationship between the versions, such as, the version 2 is backward compatible with version 1, something like that. And the second question is, it seems that you are based on the feeder with Java, and it seems that that does not consider, generic types for class and also interfaces. But I think that is also important in real-world programming. So do you consider that in your implementation, in your compiler?
Okay. Can I confirm the first question would be?
The first question is, do you study, the relationship between versions, or you just regard them as independent and they are not compatible to each other?
The first question, currently each version of the class definition is treated as independent, and there is no relation between versions. But we certainly found that we can see some relationship between different versions. For example, if we only add definitions, then we can easily prevent having some form of code clones when we generate new version of class. However, the problem would happen when we have behavior changes when we're upgrading versions. That is something that is not easily or automatically analyzable. And for other elements such as interface, we believe that it's easily extensible to this language. For generics, we still have not thought about it properly yet, because we try to first make the version itself generics, and then we will try to explore on that direction. Thank you for your questions.
Thank you. Any other questions?
Thank you for your talk. It's great that you can have use multiple versions of the same class in the same program, but there will be some point at which they will interact.
Mm-hmm.
For example, you had a slide where you had the distance between two rectangles, and maybe you're trying to get the distance between two different versions. What are your thoughts about these interactions, and is there a problem actually?
Okay. Thank you for the question. What we did so far, because it's still a very simple program, we did not see that problem yet. But of course, once it gets more complicated, that can happen. But we think this can be avoided if we provide more notations that can allow users to specify sort of allowed versions. So, for example, this method distance. For the method distance, the users can provide some form of bound for the versions of the argument. In that case, it will sort of guarantee that it will be safe for those versions. That would probably be the step that can be taken to avoid such problem from happening.
Okay. One more question.
Is the order where you put new version in relevant? So if I have like a class A and a class B, and I update A before and then I update B, or I update B before and then update A, is your inference system guaranteeing that your set of apparently unrelated class update actually have a commutative and associative property? Or there could be cases where, depending on the order in which you do apparently unrelated updates, you do get a different result in the generated code.
Answering to the previous question as well, because these classes are not the version 1 and version 2 of a class are not related to each other. We currently don't have such kind of ordering between updates as well. So that is not we don't have that in BatakJava right now, and so yeah, I think that's that.
Okay, it's thank you, Span again.